Hello guys! Here we have another system of linear equations to solve. Let's apply Gaussian elimination method. First of all, recall that we can swap equations as we like. We can add or subtract them, divide or multiply them by real non-zero numbers. Let's swap the first two equations so that we have coefficient 1 in front of x over here in the upper equation. Here's what we get. The second equation becomes the first now. X plus 3y minus z equals 0. And the first one becomes the second. Negative 2x plus y plus 2 times z equals 2. In the last equation we have 3x plus 2y plus 4z equals 3. As we know, we intend to represent the system in a triangular form. So now we need to eliminate x from all the equations except the first one. Let's begin with the second equation. To remove x from it, let's multiply the first equation by 2 and add it to the second. Here's the result. The first equation remains the same. X plus 3y minus z equals 0. Now the second. X times 2 minus 2x gives us 0. Then 3y times 2 is 6y plus y gives us 7y. Then negative z times 2 plus 2z equals 0. So 7y equals 0 times 2 plus 2, which is 2. In the last equation we have 3x plus 2y plus 4z equals 3. Now let's perform the same operation for the third equation. To remove x from it, let's multiply the first equation by negative 3 and add it to the third. The first two equations remain the same. X plus 3y minus z equals 0 and 7y equals 2. Now x times negative 3 plus 3x gives us 0. Then 3y times negative 3 is negative 9y plus 2y gives us negative 7y. Negative z times negative 3 is positive 3z plus 4z and gives us 7z. And this is equal to 0 times negative 3 plus 3, which is 3. Now our system looks like this. We have one unknown in the second equation and two unknowns in the third. We can proceed according to our algorithm, but there is no need to do this. As we can see, we have 7y here and negative 7y over here. So if we add these two equations, we will remove y from one of them. Let's remove y from the third equation, and for that, let's add the second equation to the third. Once again, the first two equations remain the same. X plus 3y minus z equals 0 and 7y equals 2. Now 7y minus 7y gives us 0. Then we have 7z, which is equal to 2 plus 3, which is 5. So now we have only one unknown in the second and the third equations. We can find y and z from them and then insert them into the first equation to find x. Let's begin with z. Z equals 5, 7. Y equals 2, 7. And from the first equation, x equals z minus 3y, which is in our case 5, 7 minus 3 times 2, 7. and equals -1/7. So this is the solution for the given system of equations. We can also write the answer in braces as -1/7, 2/7, 5/7. In this case, always keep in mind the order of the unknowns.